Hello guys, Ankesh again. Uh, Today in this session we are going to learn about reading, writing and erasing the flash of ESP32. This process comes handy while using the ESP32 while debugging the ESP32 and while testing your firmware which you make for this controller. There are multiple scenarios where you might need this tool. Of course, we also know that we can use idf.py directly after building the program to flash the chip. But there are scenarios where we sometimes are required to save the bin file from the flash memory of our controller, flash it from a bin file sent by somebody else on our controller, and erase the flash for certain reasons. For this reason, for this particular purpose, I have come up with this session wherein I'll explain how to read, write, and erase the flash memory of ESP32 using ESP2. Now, before going ahead, first we have to find out where our ESP32 is connected in this system. For this, again, we'll type list /dev/tty USB and we will do star. Okay, so our ESP32 is connected at /dev/tty USB 0. Now we have to provide permissions. So I'll write sudo chmod uo plus rwx /dev/tty USB start -v. So as you can see, the mode of /dev/tty USB 0 changed from 06602 to 0767. Now we can flash this chip. So I'll start with first reading the chip. For reading the chip and saving it in a binary file, we have to write esptool. Then we have to provide the port -p /dev/tty USB 0. Then we have to write read flash and we have to provide the size, that is 0x0000 and 0x400000. Now after that I have to provide the name of the file and the location where I want to save it. So I want to save it in my home location and I'll give it the name first first esp.bin and I will start my reading process. So here it is reading the file. So the reading process is pretty slow. So I'm going to pause this video for some time, and once it reaches 90%, I'll again restart the video so that your time is not wasted while waiting for the read process. Okay, let's come back to our video. So it's almost complete. 5% remaining, that's all. So you see a binary file will be created here. We can keep it as a backup for our build and we can continue with our future builds while always having the backup of our previous builds or initial builds that we create for a project that we do. So in this way, this is very beneficial. We can keep a record of it and use it for future validation, checking, comparison, or whatever the case may be. So let's get ahead with our task, and we see that first -esp.bin is saved in this home location. Let's check if it is present there. /home first bin is there? Yes, it is there. So now let's check the program that we had flashed in the previous video onto this chip, if it is still there. So for that we'll have to run the monitor command. For running the monitor command, we have to again run idf.py, and for doing it we have to get back to the project folder. So let's open a new terminal and We will go to the examples folder where the project resides, examples, and we were doing peripherals and UART and UART async rxdx tasks. Yes, that's our project folder. Let's see if the build still exists. Yes, we have the complete build ready and the bin file is present, as we can see in the top right corner. Now, before we can run the monitor, we have to first source the idf.py in this location. For that, we have to write source, go 4 directories up, and run export.sh from esp.idf directory. This will source our idf.py from this directory, our current project directory. Now we can run idf.py, provide the port with -p /dev/tty usb0 and monitor. Let's see if the program is still there inside the chip. Yes, it is there, it is running. So now our next task is to erase the flash. Now, to erase the flash using esptool, we have to write esptool -p to provide the port, which is /dev/tty usb0, and you have to write erase flash and press enter. That's all. So it says that the flash has been erased, and as per him, no program should be there inside the chip. Let's check it with the monitor if anything is running inside the chip. We'll use the same command for monitoring, and I'll press enter. Let's see if the program still exists inside the chip. No, the chip is in reset mode. It is in the reset state. There is no program that exists inside the esp32. Now let's get back, and now we can use the esp tool to write the bin file also. So the bin file that we read from the esp32 and saved it in the home location, let's flash that file again into the esp chip. For doing so, we have to write esp tool, provide the port -p /dev/tty usb0, provide the baud rate. We have to use the old notation of double hyphen. Baud is equal to this 460,800, and then you have to write flash. After writing write flash, you have to provide the starting location of the address where you want to start writing your binary from. So in this case, I'm giving the location as 0x0. Then once that is given, I have to provide the binary file which I have to write, which is in my home location. So I'll write home, go to my home location, and give it the binary file, that is first bin, first esp.bin, right? And one thing to keep in mind while using this command line interface, that this is a Python app from the Espressif. The ESP tool is a Python app. It will not work if you do not follow the sequence of options that we have provided here. The baud has to come right after the port value, because the baud is set by the serial driver of the laptop, not by the ESP tool app. So the baud rate needs to be provided before we give the command of write flash. So once you provide the write flash, then the ESP tool takes over and it sets the boundary for starting to write the binary file into the flash memory, and then it does what it has to do. Once the flash is written, it verifies the flash and then resets the chip. So let's go ahead and run this command. So it is writing at some speed. Okay, it is verifying the flash, and once it verifies, it hard resets the chip. Yes, hash of the data verified and hard resetting via RTS pin, and the chip has been written with the binary file that we had previously read from the same chip. Let's check whether it is there inside the ESP32 or not. So I'm going to run the monitor again. Oh yes, the program is there, and it is running inside the chip. The UART program has been flashed, and we can see that the app main is running and it receives a return value. Thank you guys for watching this video. Have a nice day.